Okay, thank you so much. I'm recording right now. You should see it in the top left that it's being recorded.
Okay, thank you. So, to start, I would like the audience to share their definition of feature engineering, and also that what is their process of turning the raw data input into the input data that their application can understand. And if they need to modify it, how do you go about doing that? So let's begin.
Let me share my comment first. This is Frank Hu from the Norfolk State University. The problem I have for me to process my data is the first one. I have to convert all the executables to the PNG image, and then you have to spend lots of time to identify those executable files, that's a DLL or exe or .com or any kind of attachment, to make sure they are the one you want. You know, every time you go to the search, you may get a meaning of them, but how to extract those good executable file that could represent your data to convert into the image, that's gonna be the big problem for me. It's manually, it takes lots of time, yes.
Yes, so what's your thought process when you decide, which executable to use? And
it's a spend lots of time to dig in the binary code or hexacode of the each. You have to write a program to another program to examine each executable file and to make sure that they have the components that you predefined. So you pick that one. So it's another long process of, if there's one automatic tool that could do this one, that's gonna be so help.
So how do you, how do you know when you have to go through additional iteration? How do you evaluate the success? How do you modify it? How do you, determine that when you need to modify it?
Yeah, we have, we always have a data set which is already spent lots of time to identify they are the one where they are the non-samples. So once when you do the executable file and then you pick up some of them, and then you do the real world simulations and you figure out that they are not the one you believe that should be the one. So that's another the try and errors. You have to have your training data, training algorithm, and then you have to have your testing or validation algorithm. Of course, the training algorithm have to be improved all the time because it's a, you have to have, that one have to learn so many new things every day. And so that's also the big problem over here. So this is not an easy task for me. So every day I spend lots of time to do this kind of thing. That's why I say you either do a tool that's gonna do it automatically. That's gonna be help.
Yes, thank you.
You're welcome.
Anybody else would like to share?
Sure. Pasquale. Yeah, please.
So I have to, hi there. I'm Pasquale Zingo from the University of Delaware. I have to absolutely agree with Dr. Hu about, it's so much of like it's a craft, it's an art almost, feature engineering. But in terms of like maybe a high level definition, I think I like Jason's, but maybe another angle that I don't think he really aimed at was injecting prior knowledge into the model. So dealing with, say, maybe a simpler machine learning model or something, linear regression, can't handle things like categorical data. And how you choose to represent that is going to make a huge difference in the model's ability to capture nuances in the data. If I have month data and I say, well, I could make January 1 and February 2, well, that's going to be a weird representation because now February is twice January, which might be good in my model, but probably not. And I could blow it out and say, okay, well, it is January, or it is February, and that's my features. And I get that, except for if I have a continuous, if my thing is responding continuously, now I've lost that nuance. And so it's all trying to find a way of representing data in a way that captures what we know must be true about the system in a way that the model can interpret it.
Yes, yes. So anyone else would like to share?
Kevin, you're here as well. May I ask you to share something as well?
Myself?
Kevin, sorry.
Oh, yes. Yeah, I'm sorry. I came into the session a little bit after it started, so I'm not sure of the prompt. Is there a specific question or?
Yeah, and can you repeat the question for Kevin?
Yes, sure. So Kevin, can you share like your own definition of feature engineering if you have one? And also, what is your process? What is your process, your work, that for feature engineering, and what's your experience on how the choice of feature engineering, this process affects the data analysis?
Yes, I feel as if it's an iterative process myself, and it with feature engineering, a bit of domain knowledge going into and understanding perhaps more about the domain as you're exploring your having good strong relationships with your outcome, your particular outcome. So sometimes you need to go and invest in trying to find out additional information that would help in your situation with data that you have to engineer more features, merging in additional data sources, coming up with approaches. Just looking back at examples, if you're trying to, predict flight delays, and you have, certain information about the flights, leaving from an airport, and then the destination airport. Well, for feature engineering, in order to maybe perhaps better predict that, tying in additional sources like the weather, right? So the weather is a strong sort of predictor of when of flight delays in general. So if you just have a data set of just flight delays, that's not enough. You need to go in and invest in other sources of data. And then because those formats could be different, you have weather stations, which may or may not be close to the airport. You have to sort of also do maybe like a distance calculation to figure out how far away your weather station might be. So then finally you'll have like hourly potential data of the weather. So then, yes, so this feature engineering is an iterative process. I think it's sort of exploring the domain and understanding the domain a little bit better, so you know what features to engineer.
So I wonder, can people share about like approximately what % of time you spend on feature engineering?
All the time.
Shall we ask people to put it in the chat, how much percentage of time? So you can find the chat on the right-hand side in the platform. And we're wondering, how much of your time do you spend on feature engineering? Is that correct, Anne?
Yeah.
Yeah. So please put it in the chat. And I'm very curious to see how much of your time do you spend feature engineering. So Sandeep says 50% of the time. Well, Kevin already answered that is about 100% of the time. And I'm curious about the rest as well. Pascal says about 85% of the time. Divyanshu says 20%. So it differs quite a bit.
Yes. So anybody does this automatically, or is it all manual?
There's some techniques, right? You can try like there's a Baruda method that you can try to do feature exploration if you already have a very long list of features and you're trying to reduce them. There's methods, PCA. I've recently encountered Baruda as a method to try to find nice associations with raw features, right? Raw attributes. But sometimes with feature engineering, you need to combine some things. But yes, I like that there are tools that help us find better predictors.
What about that finding, because you were saying that earlier, looking for additional sources of information that might help to bring that in. So how does that usually come about for you? How do you know when you need to go find more additional information?
Well, yeah, the iterative process of finding out that your models aren't, you're not, for what you're trying to train for, if it's recall, you're not getting enough recall, or you're not, you're having some issues, no matter what models you're trying, it's not giving you what you need. So if that's the issue, it's usually because you don't have the right data. And that's when you would go through that sort of process of exploring what else. Well, now that I know more about the domain, what else can I explore about that domain to go and find out additional, rich information.
Okay. So I think we have like 18 participants. I would like to hear about more experience about how people use feature engineering for their work.
Yeah, William, you unmuted yourself. Can you share a bit as well? Oh, William is gone. Okay. If anyone wants to share, please unmute yourself. Honorio, I see you unmuted yourself as well.
Oh, this is Frank again. Just try to echo the Kevin said. When it's a time when you run your model and then you feel that the unknown case get a very low accuracy or recall, then so of course the first you will examine whether this is gonna be something that's nobody know before, and then or this is something already have, but your data is not enough. So that's the two category for me. First one, of course, I can try to search more data set or more information from well-known case. And if that doesn't work, that means that that's something you're gonna get your Nobel Prize because you figure out something new. Yeah, but that's another serious case. Yeah.
Yes, well, Frankie, you brought up something that it's perfect segue to what I wanted to bring up next for discussion. Is that when I was researching for reference for my paper that I'm presenting tomorrow, I could not find any references. And I guess because I couldn't even think of like, what is the proper term for that? That was before I heard of the term feature engineering. So in statistics, we just kind of do this automatically. We gather data, we massage the data, we play with the data, and then we plot it, we do all kinds of things until we think, by the time you're kind of done a lot of exploration, you already kind of get an idea of how you want to analyze it, so you then feed it to the appropriate software. So I could not find any reference because like I said, I don't know what the appropriate keyword is. So I Google like data pre-processing and whatnot. I didn't find a lot of hit until just recently. I was listening to a machine learning lecture. I heard about feature engineering. I was like, oh, this sounds like it's the keyword. So I Googled it, and found the definition. And I was really happy and feel validated to see in that blog that I shared by Jason that he also talked about how important it is, how time consuming it is, and yet not many papers and chapters and talk about it. And I have a feeling in part was because it's hard to describe it. There's not like a method or tools that you can say to do this and like get Nobel Prize, get recognition. But there's a lot of the hard work is in your head, is in thinking, So because now I've got a feeling that audience here also agree that this is a very time consuming yet very critical steps, that I wonder what your thought on how can we increase, the I guess the visibility, how can we increase the awareness of this step in the research community? Because I personally am not aware of it until I read the blog, but it said, he mentioned that many machine learning competition was won, not so much by the method it deploys, but by how appropriately they feature engineers the input. So I completely agree, because I feel like machine doesn't know to go out and gather the right data for itself, right? We are the one who could feed it to it. So so I was wondering what's your thought on how this can be improved?
Pascal, I saw you nodding a couple of times. I'm very wondering, should we increase invisibility? Is that something you think is important as well?
Sorry.
Go ahead.
I was gonna say, no, I was nodding because I completely agree. It seems like is the term cursed problem track with anybody here? It's sort of like the issue with feature engineering, it seems, is that it's a difficult thing to measure and compare. Machine learning models, it seems like, are really easy to publish because you can say, oh, here's the one from last year that had the best results, and we did 0.5% better than that one. Feature engineering, it's kind of like I had said earlier, it feels like a it's like trade almost. It's a skill that people kind of get. It's very problem dependent, which makes it, I think, really difficult to talk about in like the academic sense, where you want to be able to show like provable improvements over a existing method. So I'm a PhD student, so that's just sort of what it's looked like for me for the first couple of years in the field. I'm really interested to see if anyone else has ideas about how you can make that academically, I don't know, interesting as a publication idea.
Yes, exactly. Any suggestion?
Frank, I saw you nodding your head a couple of times as well. Would you agree as well? And maybe you have some suggestions on how to go about doing this? I'm not sure how to call you, Yin Jung or Frank, but I am curious about your opinion.
Oh, it still had lots of the publication opportunity or the research opportunity for feature engineering, because we know that most of the we will say the trade secret or those kind of information in the whole by Google, Facebook, and Microsoft, Intel, IBM. And there's no way that we could get those information or those data set. But in the academy, that you still could develop some kind of I would say that's the semi-real world model, which is adaptive. So that means that you could improve it by yourself. You could plug in more those kind of codes where the keywords about or some kind of category you try to looking at. In the interest of course, that's gonna be expand the capability of your tools. But since the problem we have is the different subject, the data sets is always be different. COVID-19 is it's a very hot topic right now, and so people always thinking about how to do is deep learning or machine learning to figure out those kind of cure or any kind of, the possibility that they could do. And those kind of information is, of course, totally different to the thing I have. I'm doing the malware analysis. So it's always be some kind of research topic. That's how could you identify your purpose, and then it's not very rough. It's not very tough, but you have to understand where you're gonna go. You're gonna go which subject, and as long as you have can solve those to help people to do the work on one subject, you are good enough. You are very valuable. Okay. And then so you could lots of publication over there. So you're a PhD student, you have so many things to do in the subject that you look at.
Okay, I will share something from my work that which is kind of what motivated me to come up with the method that I'm presenting tomorrow. Is that in a sort of a higher academic area, right? If you're like a graduate student or you're working for a researcher, that's not in computer science or whatnot. Usually, you do all this feature engineerings, and then interacting, getting feedback with the domain expert. So now, in my case, where we were doing data mining of electronic health records on real life veteran health data, that it's kind of like almost two very distinct bubbles. One bubble was people like me that do all the feature engineerings and communicate, with another bubble that is the professors that do clinical research and publication. Okay, so that even though we would do a lot of back and forth, so the iterative is between two different people. Now, when I was working on a different industry in a different project, when I am how should I say this? I kind of like, do both parts in the same bubble. Okay, so I kind of know that how to manipulate the data and what is the ultimate goal that I need to achieve. But when you have two separate bubbles, it makes it kind of difficult, especially I think that if you are in a more of academic situation where publication, is very important, then I think the emphasis is more on the method development after the feature engineering is already done, and I feel like there could be a danger in that, because I feel like to be a very good, thorough analysis of results, there really shouldn't, the two bubbles really should overlap more and more, okay? Because the data, after all, that will solve a problem, like Frank was saying, that there are like additional sources of data that may be needed. If you have two separate bubbles, the clinical expert, right, the expert side may not know what other sources of data that is out there, or the analyst, because they have to be doing all the extracting and cleaning and whatnot. They know what how to get those extra sources of information. So I feel that's kind of how I feel that there is a potential risk of separating the feature engineering from the analysis itself, and so, yeah, I don't know how to solve that, but I just think that there need to be perhaps more recognition from the publication or from the domain expert field itself to recognize that feature engineering is not separate. It's really an integral part of the same analysis discipline.
Makes sense to me. It's almost time. If people want to know more, they can follow your paper presentation tomorrow. Is that correct?
Yes.
Okay. Can you tell briefly what it's about and what you will talk about tomorrow?
So, okay.
Briefly.
Briefly, sure. So it's a way of creating features that are very complicated, that are interdependent in time. So like when you go to see a doctor, right, for your diagnosis, and every doctor will look at your records, electronic records, and then try to figure out how is your medication or treatment, whatever history that you have, can be interpreted to your current complaint. Okay, so they never interpret. Those interpretation is also depending on the time, because if you go today versus you go 10 months later, right, those information will be interpreted differently for whatever the complaint that you have at a time. So we do that a lot when we do data mining of EHR. So I came up with a way of making those creating those complicated feature much faster.
Okay, well, if you want to know more, then tune in tomorrow for paper presentations. This is it for this virtual roundtable. You can join the paper presentations after this. We've got one on security and privacy, data science, the Internet of Things, computing, and the final one on agents and multi-agent systems. And after that, we'll have a keynote of the Office of the Future. Thank you so much for joining, and thank you so much for hosting. We'll see you later.
Thank you so much for co-hosting.
Thank you. Thank you.
Thank you.
Thank you.